When planning electrical circuit routing for a 6-room apartment, several key considerations will ensure safety, efficiency, and compliance with electrical codes. Firstly, divide the apartment into distinct circuits based on function and load. A general lighting circuit should encompass all lighting outlets throughout the apartment. A small power circuit will supply power to general use outlets for small appliances and electronics. Dedicate a separate circuit specifically for kitchen appliances such as the refrigerator, oven, and dishwasher. Similarly, the bathroom should have its own circuit to power lighting, exhaust fans, and electrical outlets. A dedicated circuit is also necessary for the washer and dryer in the laundry area. Additional circuits can be added as needed for specific areas like a home theater or outdoor outlets. After establishing the circuits, plan the physical routing of the wires. Begin at the main electrical panel, identifying the location of the circuit breakers that will control each circuit. Run cables from the panel to junction boxes strategically placed within each room. During cable routing, prioritize minimizing cable lengths and avoiding obstructions. Select appropriate cable sizes and types for each circuit. For example, use number 14 American wire gauge THHN wire for lighting circuits and number 12 American wire gauge THHN wire for appliance circuits. Junction box placement is crucial for accessibility and future modifications. Position junction boxes at convenient locations for easy connections and future expansion. Install boxes near light switches, outlets, and appliances. Always use approved junction box covers to protect the electrical connections. Outlet and switch placement must adhere to electrical codes. Provide an adequate number of outlets in each room to accommodate appliances and electronic devices. Place switches near doorways for easy access. Load balancing is a critical aspect of circuit design. Distribute the electrical load evenly across all circuits to prevent overloading. Use circuit breakers with appropriate amperage ratings for each circuit. Calculate the maximum wattage of appliances and devices that will be used on each circuit to ensure it does not exceed the breaker's capacity. When documenting the circuit routing, use a CAD program or drafting paper to create a detailed plan. This plan should include the location of the main electrical panel, junction boxes, outlets, switches, and circuit breakers. Clearly label each circuit and include a legend for easy interpretation. Several additional factors are critical for safety and code compliance. Always adhere to all applicable electrical codes and standards. Use insulated splices and connectors to ensure proper wire connections. Proper grounding is essential for all outlets and fixtures. When in doubt, consult with a qualified electrician for guidance and certification. To elaborate further on circuit division, consider the typical electrical loads in each room. For the general lighting circuit, calculate the total wattage of all light fixtures to ensure it doesn't exceed 80% of the circuit breaker's rating. A 15 amp circuit, for example, should not exceed 1440 watts, calculated as 120 volts multiplied by 15 amps multiplied by 0.8. For small power circuits, factor in the anticipated use of small appliances like phone chargers, lamps, and other low-power devices. Kitchen circuits require careful planning due to the high power demands of appliances. The refrigerator should ideally have its own dedicated 15 or 20 amp circuit depending on its size and energy consumption. Ovens and dishwashers also require dedicated circuits, often rated at 20 or 30 amps, depending on their wattage. Consult the appliance's nameplate for specific amperage requirements. Bathroom circuit should be ground fault circuit interrupter protected to prevent electrical shock hazards. The laundry circuit must be rated to handle the high current draw of washers and dryers. A 20 or 30 amp circuit is typically required, and a dedicated circuit is always recommended. The choice of wire size depends on the circuit's amperage rating and the type of insulation. Number 14 American wire gauge copper wire is typically used for 15 amp circuits, while number 12 American wire gauge is used for 20 amp circuits. Number 10 American wire gauge is suitable for 30 amp circuits. Always refer to the National Electrical Code, NEC Table 310.15b16 for ampacity ratings of conductors. When routing cables, avoid running them through areas where they might be exposed to physical damage or excessive heat. Use conduit or protective sleeving in such areas. Secure cables to building structures using cable staples or clamps, ensuring that they are properly supported and not subject to strain. Junction boxes must be accessible and should not be concealed behind walls or ceilings without access panels. Ensure that all wire connections within junction boxes are secure and properly insulated using wire connectors or electrical tape. Grounding is a critical safety measure. Connect all metal enclosures, such as junction boxes and appliance housings, to the grounding system. Use a grounding conductor, typically bare or green insulated wire, to connect these enclosures to the main grounding electrode system. All outlets should be grounded, and ground fault circuit interrupter protection should be provided in bathrooms, kitchens, and outdoor locations. The National Electrical Code outlines specific requirements for grounding and bonding. Consider future expansion when designing the electrical system. Provide spare capacity in the electrical panel and run extra conduit to strategic locations to allow for future circuits or upgrades. Label all circuit breakers clearly and create a circuit directory to identify which circuits serve which areas. Keep this directory updated as changes are made to the electrical system. When selecting circuit breakers, choose those that are appropriate for the type of load they will be protecting. Standard circuit breakers are suitable for general lighting and appliance circuits, while ground fault circuit interrupter breakers are required for bathrooms and outdoor circuits. Arc fault circuit interrupter breakers provide additional protection against electrical fires caused by arcing faults. Always consult with a qualified electrician to ensure that the electrical system meets all applicable codes and standards and is safe for its intended use. In planning the layout and distribution of electrical circuits, further attention should be paid to energy efficiency and future adaptability. Consider the use of LED lighting, which consumes significantly less energy than traditional incandescent or fluorescent lighting. Implement smart home technologies, such as dimmers and occupancy sensors, to further reduce energy consumption. During the design phase, anticipate future needs by incorporating additional outlets and spare capacity in junction boxes. This will facilitate the addition of new devices and appliances without requiring extensive rewiring. The electrical panel should be sized appropriately to accommodate current and future loads. A larger panel with more available breaker slots provides greater flexibility for expansion. Clearly label all circuits in the panel with detailed descriptions of the areas and devices they serve. This will simplify troubleshooting and future modifications. When running cables, use a consistent color coding scheme to identify different circuits and wire types. This will aid in identification and prevent confusion during installation and maintenance. Consider the aesthetic aspects of electrical installations. Conceal wiring whenever possible to maintain a clean and uncluttered appearance. Use recessed lighting fixtures and flush-mounted outlets and switches to minimize visual impact. Proper ventilation is essential for electrical equipment. Ensure that the electrical panel and other components are located in well-ventilated areas to prevent overheating. Avoid installing electrical equipment in damp or humid environments, as this can lead to corrosion and electrical hazards. Regularly inspect the electrical system for signs of damage or wear. Check for loose connections, frayed wires, and cracked insulation. Address any issues promptly to prevent potential hazards. Keep a detailed record of all electrical work performed, including circuit diagrams, equipment specifications, and inspection reports. This documentation will be invaluable for future maintenance and troubleshooting. When making any modifications or additions to the electrical system, always obtain the necessary permits and inspections. This will ensure that the work is performed safely and in compliance with applicable codes and standards. Educate occupants about electrical safety and the proper use of electrical equipment. Provide instructions on how to identify and respond to electrical hazards. In multi-unit dwellings, coordinate electrical work with other residents to minimize disruption and ensure safety. Clearly communicate any planned outages or potential hazards. When selecting electrical contractors, choose those who are licensed, insured, and experienced in residential electrical work. Check their references and verify their credentials before hiring them. The National Electrical Code is a comprehensive set of standards for electrical installations. Familiarize yourself with the requirements of the NEC and ensure that all work is performed in accordance with its provisions. Consider the impact of electromagnetic fields, EMFs, generated by electrical wiring and equipment. Minimize exposure to EMF by maintaining a safe distance from electrical sources and using shielded cables. Implement surge protection devices to protect sensitive electronic equipment from voltage spikes. These devices can prevent damage to computers, televisions, and other appliances. Regularly test ground fault circuit interrupter outlets to ensure they are functioning properly. These outlets can save lives by preventing electrical shocks. Consider the use of energy-efficient appliances and devices to reduce overall energy consumption. Look for the Energy Star label when purchasing new appliances. Implement a regular maintenance schedule for the electrical system, including inspections, testing, and repairs. This will help to ensure its continued safe and reliable operation. Stay informed about the latest advancements in electrical technology and incorporate them into your designs and installations whenever possible. This will help to improve efficiency, safety, and performance. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable performing a task yourself, hire a qualified electrician to do it for you. When working on electrical circuits, always de-energize the circuit at the breaker panel and verify that it is de-energized using a voltage tester before touching any wires. Wear appropriate personal protective equipment, PPE, such as safety glasses and interlated gloves, to protect yourself from electrical hazards. Never work on electrical circuits in wet or damp conditions. Keep a fire extinguisher nearby in case of an electrical fire. If you smell burning plastic or see smoke coming from an electrical outlet or appliance, immediately shut off the power and call the fire department. Properly dispose of old electrical equipment and materials to prevent environmental contamination. Recycle whenever possible. Encourage others to practice electrical safety and report any potential hazards to the appropriate authorities. By following these guidelines, you can help to ensure the safety and reliability of electrical systems in residential buildings. Additionally, it's beneficial to understand the concepts of voltage drop and its impact on circuit performance. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the wires. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. To minimize voltage drop, use appropriately sized wires and keep circuit lengths as short as possible. The National Electrical Code provides guidelines for calculating voltage drop and selecting the appropriate wire size. Consider the use of home automation systems to control lighting, appliances, and other electrical devices. These systems can improve energy efficiency, enhance convenience, and provide added security. Integrate renewable energy sources, such as solar panels, into the electrical system to reduce reliance on fossil fuels. This can save money on energy bills and reduce environmental impact. Implement a smart grid system to optimize energy usage and improve grid stability. This involves using advanced technologies to monitor and control energy flow throughout the electrical grid. Regularly update your knowledge of electrical codes and standards to stay abreast of the latest changes and best practices. Attend training courses and workshops to enhance your skills and knowledge. Join professional organizations such as the Institute of Electrical and Electronics Engineers, IEE, to network with other professionals and stay informed about industry trends. Consider the use of surge arresters at the main electrical panel to protect the entire electrical system from voltage surges caused by lightning strikes or other events. These devices can divert excess voltage to ground, preventing damage to electrical equipment. Implement a power quality monitoring system to detect and analyze power quality problems such as voltage sags, swells, and harmonics. This information can be used to improve the performance and reliability of electrical equipment. Consider the use of uninterruptible power supplies (UPS) for critical equipment such as computers and servers. These devices provide backup power in the event of a power outage, preventing data loss and downtime. Implement a grounding electrode system that meets the requirements of the National Electrical Code. This system provides a low impedance path for fault currents to return to the source, helping to protect against electrical shock hazards. Regularly inspect the grounding electrode system to ensure that it is in good condition and properly connected. Consider the use of isolated ground receptacles for sensitive electronic equipment. These receptacles provide a separate grounding path to minimize noise and interference. Implement a bonding system to connect all metal parts of the electrical system together, creating a low impedance path for fault currents. This helps to prevent voltage differences between metal parts, reducing the risk of electrical shock. Regularly inspect the bonding system to ensure that it is in good condition and properly connected. Consider the use of arc flash protection measures to protect workers from the hazards of arc flash events. These measures include using arc-rated clothing and equipment, implementing safe work practices, and conducting arc flash hazard assessments. Implement a lockout/tagout program to prevent accidental energization of electrical equipment during maintenance and repair work. This program involves using locks and tags to isolate electrical circuits and prevent them from being turned on accidentally. Regularly train workers on electrical safety practices and procedures. This training should cover topics such as hazard recognition, safe work practices, and emergency response procedures. Consider the use of remote monitoring and control systems to manage electrical equipment from a central location. This can improve efficiency, reduce costs, and enhance safety. Implement a preventative maintenance program for electrical equipment to identify and address potential problems before they lead to failures. This program should include regular inspections, testing, and lubrication. Consider the use of predictive maintenance techniques to anticipate equipment failures and schedule maintenance activities accordingly. These techniques involve using sensors and data analysis to monitor equipment condition and predict when maintenance will be required. Implement a reliability-centered maintenance (RCM) program to optimize maintenance activities based on the criticality of equipment and the potential consequences of failure. This program involves analyzing equipment failure modes and effects and developing maintenance strategies to minimize the risk of failure. Consider the use of condition-based maintenance (CBM) techniques to monitor equipment condition and schedule maintenance activities only when needed. These techniques involve using sensors and data analysis to assess equipment condition and trigger maintenance activities when certain thresholds are exceeded. Implement a computerized maintenance management system (CMMS) to track maintenance activities, manage inventory, and generate reports. This system can help to improve efficiency and reduce costs. Regularly audit the electrical system to identify areas for improvement. This audit should cover all aspects of the electrical system, including design, installation, operation, and maintenance. Consider the use of third-party certification programs to demonstrate compliance with industry standards and best practices. These programs can help to improve credibility and enhance customer confidence. Stay up to date on the latest regulations and standards related to electrical safety and efficiency. This includes the National Electrical Code, the Occupational Safety and Health Administration (OSHA) regulations, and the Energy Star program requirements. Implement a continuous improvement program to identify and implement changes that will improve the performance and reliability of the electrical system. This program should involve all stakeholders, including engineers, technicians, and management. By following these guidelines, you can ensure that the electrical system is safe, reliable, and efficient.